Chapter 8 Matrices. So in this chapter, we're going to talk about 8.1 matrix algebra and the systems of linear equations. We're going to work on determinants so that we can use determinant to find the inverse of matrix, Cramer's rule, and last section for this chapter is going to be eigenvalue problem. Matrix algebra. Definition of the matrix is the rectangular array of number of functions. Our textbook uses this form and like a parenthesis type of symbol to indicate the matrix. However, I want to use this square bracket, and the numbers or functions in the array are called entries or elements of the matrix. If a matrix has n rows and n columns, we say the matrix or dimension of that matrix is m by n. If the number of rows and number of columns are the same, we call square matrix, n by n matrix. And the row matrix or row vector or column matrix or column vector can be represented as 1 by n or n by 1. m by n, this is the row and this is the column. In your first quiz, after you do matrix algebra, give me the number for a sub 3, 2. That means this is the row and this is the column. So that means we have A, B, C, D, E, F, G, H, I. That means third row. This is third row. And then second column. So the second column, the answer should be H. And we can multiply scalar to the matrix. That means you need to multiply that K to every single element in the matrix. When you multiply two matrices, the dimension is really important. Okay? So if A is n by m and B is m by p, we can multiply these two because inner number for the dimension is the same and the result is gonna be outer number, n by p. So we're gonna work on some problems later. Associative law, and as long as you keep this order same and we can multiply them, then it should be fine. So let's work on this problem. So A, we need to multiply A times B. Also, book says only A times B, but we're gonna check B times A as well. So we have A 2 by 2, B 2 by 2, and inner numbers are the same. So result is outer number. So A times B equals, and when we multiply, we need to multiply row by column. So the first row and first column is gonna be here, and that is 4 times 9 plus 7 times 6, and then first row, second column is gonna be first row, second column. So 4 times -2 plus 7 times 8. We're gonna work on the second row. So then second row, first column, gonna be here, 3 times 9 plus 5 times 6. Second row, second column, here, 3 times -2 plus 5 times 8. That is 36 plus 42. Therefore, it's going to be 78. Second number is -8 plus 56. It's going to be 48. Second row, first column, 27 plus 30, which is 57. And -6 plus 40, 34. And B times A. So we have
9, 6, -2, 8. A is 4, 7, 3, 5.
First row, first column, 9 times 4 plus -2 times 3. First row, second column, 9 times 7 plus -2 times 5. Second row, first column, 6 times 4 plus 8 times 3. And then second row, second column, 6 times 7 plus 8 times 5. That is 36 minus 6, 30, 63 minus 10, 53, 24 plus 24, 48, 42 plus 40, 82. As you can see, AB is not the same as BA in square matrix. What about just addition and subtraction? We have A plus B, 4 plus 9. Just go by element, and then 7 minus 2, 3 plus 6, 5 plus 8, that is 13, 5, 9, 13. And if it's subtraction, just need to change positive to negative. Part B, the first was the dimension of this row by column, 3 row by column, 2 column, and this is 2 by 2, and then inner number, good, they do match. Outer number is the result. A times B is gonna be 3 by 2, meaning 3 rows and then 2 column. First row, first column, plus 8 times 2. First row, second column. Second row, second column. Second row, second column. Third row, first column. Third row, second column. That equals
Negative 20 plus 16, negative 4. Negative 15 plus 0, negative 4 plus 0, negative 3 plus 0, negative 8 plus 14, positive 6, negative 6 plus 0.
What about B times A? So the dimension of the B is 2 by 2, and then dimension of A we said 3 by 2. So these two inner numbers, they are not the same, so this is not possible. And A plus B, A minus, because they don't have the same dimension, so it's not possible. Transpose matrix. So if you are given matrix A, and if you want to find the transpose matrix, you're going to put row into column. So let's say if we have A as A, B, C, D, E, F, then a transpose matrix is going to be this row to column. So A, B, C, D, E, F. If the A is n by n, then a transpose matrix is going to be n by m. That makes sense. And here are some properties of transpose matrix. You can take a look at it. Some special matrices, zero matrix, all entities are 0. And triangular matrix and diagonal matrix, you take a look at it. And then identity matrix is important one called I2. That means diagonal ones is 1 and all others is 0. And then identity matrix 3, so 3 by 3. Okay, so for the quiz, so do this and then give me, we're gonna call the result as a M matrix, and give me the matrix M2, 3 or M1, 3 or M3, 2. So let's find the M first, and this is 3 by 2, 3 by 2. So they are the same dimension, so we can add them together. So let's find A plus B first. Negative 2 plus 3, element by element, 0 minus 1, 4 plus 0, 1 plus 2, 7 minus 4, 3 minus 2, and that is 1, negative 1, 4, 3, 3, 1. So M, second row, third column, not exist. Second row, we have only 2 columns. First row, third column does not exist. And then third row, second column. Or M31 equals to 3. And then M21, second row, first column. So you should know, always row by column.